This channel does not promote or encourage any illegal activities. All contents provided by this channel is meant for educational purpose only.
Generating payloads with Msfvenom. So welcome to the client-side attack section of this course. Now that we've essentially explored the process of performing information gathering, enumeration, as well as vulnerability scanning, we can begin exploring exploitation. And the first type of exploitation, or the first attack vector that we will be exploring, are client-side attacks. And in order to perform a client-side attack, we'll need to know how to generate the Metasploit framework payloads. And in order to generate these payloads, we'll be utilizing a utility called Msfvenom. All right, so let's get started first and foremost by understanding what client-side attacks are and how they differ from host-based attacks or service-based attacks. All right, so a client-side attack is an attack vector that involves coercing a client to execute a malicious payload on their system that consequently connects back to the attacker when executed. Now, client-side attacks will typically utilize various social engineering techniques like generating malicious documents or malicious portable executables in the case of Windows, and in some cases in the form of a Debian package for Linux. Now, client-side attacks, and this is where the difference comes into play, take advantage of human vulnerabilities as opposed to vulnerabilities in services or software that's running on the target system. So depending on the way the target operating system or the target system has been configured, you'll need to again structure or coordinate your attack accordingly. So I'll give you an example here. If the target system that you're trying to attack or you're trying to gain access to has been configured as a server, so for example, it's running Windows Server and it's used to host business critical applications, or a web server, for example, then our attack vector would be a host-based attack or a service-based attack, whereby we will be trying to find vulnerabilities within the services that are running on that system. Now, if the target system that you're trying to attack has been configured to run as an end-user operating system, so let's say you're trying to target an employee laptop or an employee workstation, then you'll need to change your attack vector to a client-side attack, where your job will be to first and foremost generate a malicious payload, either for Windows or Linux. And then secondly, you can utilize social engineering techniques like, essentially generating malicious documents, or making the payloads look as enticing as possible, so that you're essentially trying to convince the client or the target employee, in this case, to actually click on that payload. So this is where social engineering comes into play. Now, we are not going to be covering the various social engineering techniques within this course, as that is beyond the scope of this course. But a simple example or a scenario would be that we generate a Windows payload, right, with Msfvenom. Once we've generated the payload, we can then inject the payload into another legitimate Windows executable, therefore making it look legitimate, and then we can distribute this to the client or the target employee, either through email or maybe through another type of communication channel. And once it's on their system, they will click on it and consequently execute the payload. Now, when they execute the payload, we need to be ready with a handler, or a listener rather, that will essentially receive the incoming connection. And once they again execute it on their target system, and once we have the listener set up, we should be able to receive a connection back from the target system and consequently gain access to the target system. Now, one thing to keep in mind is that given that the client-side attack vector involves the transfer and storage of a malicious payload on the client system, primarily being on their disk, we also need to be cognizant of antivirus detection, right? So again, because we're essentially trying to send a payload or trying to get a target employee or individual to download a malicious payload and then execute it on their system, we need to be aware of the fact that their system could have an antivirus solution installed that could consequently detect or find that this particular payload is malicious and prevent the target individual from executing it. So we'll also be exploring the process of encoding payloads with Msfvenom. And then finally, to wrap up this section, we'll be exploring the process of essentially generating or injecting our payloads into a legitimate executable to make it look as enticing as possible. All right, so we've talked a little bit about what Msfvenom is, or rather I've given you a basic description, but really it's a very simple tool to understand. Msfvenom is a command line utility that can be used to generate and encode Metasploit framework payloads for various operating systems as well as web servers. Now, if you've used the Metasploit framework for probably, I would say before the last 5 years, then you would know that Msfvenom is really a new utility and is a combination of two previous utilities known as MSF Payload and MSF Encode. So MSF Payload was used to generate payloads, and then MSF Encode was used to encode payloads. They were two separate utilities, but now they actually joined into one called Msfvenom, and Msfvenom is part of the Metasploit framework. It's a Metasploit framework utility, and it comes pre-packaged with Kali Linux, so you don't have to actually download it or install it manually. Now we can, in this particular scenario, we can utilize the Msfvenom to generate a malicious meterpreter payload that can then be transferred onto the client target system. Once executed, it will connect back to our payload handler and provide us with remote access to the target system. And I'll also be explaining what a handler is in the context of a meterpreter payload. So now that we have an understanding of what we're going to be doing, and what we are essentially going to be covering within this section, let's get started with the first practical section, which is how to generate payloads with Msfvenom. Alright, so I'm back on my Kali Linux VM. In this case, you don't need a lab environment to follow along with the techniques. As I said, this is a client-side attack, so we're essentially just taking a look at how to generate payloads. So in terms of running Msfvenom, it's fairly simple to understand, or rather to use. We can just type in MSF and then Venom, hit enter. And as you can see, that will open up the documentation, and it gives you an idea of what this tool is and what it's used for. So as you can see, it says Msfvenom is a Metasploit standalone payload generator, and it's also a replacement for MSF Payload and MSF Encode. So it gives you some usage examples here, and you can take a look at all of the options here. Now I'm going to be explaining some of the key elements of Msfvenom that you need to understand. As you know, previously during the earlier section or the introduction section of this course, I briefly explained the two types of Metasploit framework modules available, one of which was a staged payload, where the payload would essentially be sent in two parts, and then you have the non-staged or inline payloads, where the payload is essentially sent along with the exploit as a whole. And with Msfvenom, you can generate both of these types of payloads. But before we do that, if you want to list out the available payloads you can generate with Msfvenom, you can type in Msfvenom and then list out the payloads. So I can say list payloads, give that a few seconds, as there are quite a few payloads here. Alright, so as you can see, this will provide you with a list of all available payloads that you can generate with Msfvenom. And as you can see, there are quite a lot. However, in this course and in this case, we're going to be focusing primarily on the meterpreter payload. And as we already know, the meterpreter payload also allows you to specify the target architecture of the target operating system. So you can generate a x64 payload, which is a 64-bit payload. You can also generate a 32-bit payload, where, again, if I can actually identify this or actually find it here, I should be able to show you that. And then, of course, I'll explain the difference between a staged meterpreter payload and a non-staged payload. Right, so again, hopefully I can find the Windows meterpreter payload here. This is the one. So this is a standard 32-bit payload, and Msfvenom allows you to specify the target operating system architecture when generating a payload. So now let's explore or understand the difference between a staged payload and a non-staged payload in the context of how they differ in terms of their name. Because again, when generating a payload, you'll need to specify the exact type of payload that you'll want to generate. So if we take a look at a quick example here, I'm just going to scroll down a little bit here, and hopefully I can find an example that will actually work or that will make sense. All right, so let's take a look at this one here. So as you can see, this is a meterpreter payload. So let's start off with the target operating system. So whenever you're specifying a payload, you start off by specifying the operating system, which in this case is Windows. Now Linux also has its own meterpreter payloads, and I'll get to them in a second. and then you specify the target operating system architecture, or the actual architecture, or rather the type of payload you're trying to generate in regards to the target operating system architecture. So if I generate a 64-bit payload, I cannot run the payload on a 32-bit operating system. So you need to be very cognizant of that. And then after that, we specify the payload type. In this case, as you can see, this is a meterpreter payload. And then after this, you specify the protocol that you want to use to actually connect back to the attacker operating system. So this will again depend on your own use case and the target environment that you are going to be deploying your payloads on. So a good example of this is whenever you're trying to again utilize the reverse HTTP or HTTPS payload. This is very good if you're trying to mask the connection as legitimate, because remember, this is a reverse connection, which means once this payload is executed on the target system, it will connect back to the attacker system, and in this case it will go through an HTTP or an HTTPS port, which again will help mask the activity, as a connection to another port on an attacker's system will be extremely suspicious. So that's again in the context of TCP. So again, the type of protocol we'll use will depend on what your requirements are. Now, this is a staged payload, right? And the way you can tell the difference is because you're specifying meterpreter, and then there's a / and then you specify the protocol that you want to use. Now, an example of a non-staged payload is one here. As you can see, this is you specify the operating system architecture, and then you specify meterpreter. However, instead of there being a / you can see that it says right over here _reverse HTTP. So this is as you can see, a non-staged payload, and this over here is a staged payload, and it gives you an example of what this payload is used for. So you can see it says this will inject the meterpreter server DLL via reflective DLL injection, and this is staged, of course, and this will require Windows Windows XP Service Pack 2 or newer. So it'll give you an idea of what target operating systems this will work on in the context of Windows. And this will tunnel the communication over HTTP. Now, in the case of TCP, and I'll just again explain this really quickly, you can see it'll connect back to the attacker based on whatever port we specify. Now, we also have Linux payloads, and they look exactly the same, except, of course, the operating system is specified differently. So let me see if I can find one through the list here, as that is quite important. There we are. So we have the Linux payloads here, and this is the 32-bit meterpreter payload. This is a staged payload, as you can see here. And then, of course, you have your non-staged payloads. Hopefully I can find them here. Your non-staged Linux payload. So there we are. You can see Linux x64 meterpreter. That's a staged payload, and then this is the non-staged payload. So they look very, very similar. So let's get started, and we'll explore a little bit of the functionality. So whenever you're trying to generate a payload with Msfvenom, you type in Msfvenom, and then you specify the target architecture. This is not always required, but it is quite useful. So if I want to generate a 32-bit payload, I can type in x86, right? And then after this, I specify the actual payload using a -p. So if I want to generate a Windows payload, let's start off with Windows. I can say, again, Windows, and then I can specify the target architecture. But in this case, it's a 32-bit payload. So I can say Windows meterpreter reverse _TCP or HTTP or HTTPS, depending on your own requirements. I can also specify a non-staged payload if I want. All right, so we are specifying the payload. Now we need to specify the attacker's information. So what IP address will this payload connect to? So in order to do that, we're going to say lhost is equal to, and this is where you specify your Kali Linux VM IP or your Kali Linux IP. And in my case, that is 10.10.10.5. And in the case of TCP, we can specify the actual port to connect back to, or rather the port that the payload will connect back to. And in this case, I'm just going to say 1234, just to keep things simple. Now, this is where the important part comes into play, and that is the output format. So we can generate this payload or essentially output or generate this payload and output it into an exe file so that it can directly be executed on the target system. In order to do this, we specify the format option, and then we say exe. And then we can output it and say we want to output it onto my desktop. So I'm going to say home Kali desktop. And in your case, you can change the actual storage directory. And I'm going to store it into a folder that I created called Windows Payloads. And then I need to provide it with a name. So I'm going to call this payload, I'm just going to say payload x86.exe. It's very important that you specify the extension here. So I'm going to hit enter. Give that a few seconds. All right, as you can see, it's going to say no platform was selected. So we can specify the platform, but in this case, because we are highlighting the payload that we want to use, which is a Windows meterpreter reverse TCP payload, it's going to say it's going to utilize the platform specified from the payload. It's then going to say no encoder specified, outputting the raw payload. The payload size is 354 bytes, and the final size of the portable executable is 73,802 bytes. So if I head over onto my desktop and under Windows Payloads, you can see that it generated the payload x86.exe. So you can now transfer this over to the target system, or you can essentially set this up in a social engineering campaign and somehow get the target employee or the person you're targeting to download it and then execute it on their system. However, before they execute it, you need to set up a handler. And before we actually get into how to set up a handler, let's take a look at how to generate another type of payload, or rather changing the actual architecture of the payload that we're generating. So to generate a 64-bit meterpreter payload, I'm just going to head over here into the previous command, and we're going to change the architecture to x64. And then as well as in the payload, we are also going to say this is an x64 meterpreter payload. We're going to leave the L host and the L port options the same, and we're going to output it into the exe format and save it as payload x64.exe. So it's really that simple in regards to, again, changing the architecture. So I'm going to hit enter. That is again going to take a few seconds. All right, as you can see, that again generates a 64-bit meterpreter payload, and it outputs it into the file name that we specified. So again, it gets the actual platform from the actual module or the payload that we specified, and then it says the final size is 671 or rather 7,168 bytes. So if we list out the contents of the Windows Payloads directory, you can see that we have the payload x64.exe, which is suitable for 64-bit versions of Windows. And the 32-bit payload here can be executed on both 32-bit versions of Windows as well as 64-bit versions of Windows. So it's entirely up to you in regards to what to actually what type of payload you want to generate in terms of the architecture here. Now, I've talked about the output format, but I didn't take you through all of the output formats available. You can list out the output formats available by typing in Msfvenom. And then if I say list and say formats, that will provide you with a list of formats that you can output your payloads into. And we'll give this a few seconds here because there are quite a few. And they're sorted based on executable formats. So these are the formats that can be directly executed, and they're sorted based on the target operating system and or platform. And on the bottom here, you have the framework transform formats, which allow you to output the payloads into either a Python file, a Ruby file that can then be modified later, or even a hex file if you want. So you can output your payloads into any of these other formats here. However, if you want an executable file, so you can output it into an ASP file, ASPX, ASPX exe, a DLL file for Windows. So if you're trying to generate a malicious DLL file, you can do that. If you're trying to generate a malicious Linux binary, you can use the ELF option. If you're trying to generate a malicious Linux shared object file, you can use the ELF shared object option. If you're trying to generate a Windows executable, you can say exe or exe only, exe service, exe small, etc., etc. And then, of course, you have your other options here for Java or Java web servers. So you have your jar file, JSP file. You can also generate MSI files for Windows, as well as OS X or Mac OS X app files for execution on Mac OS targets. And you have various other output formats that are executable. So now that we've explored that, let's try and take a look at how to generate Linux payloads with Msfvenom. And the process is, again, exactly the same. The only thing we're changing is the target operating system and, of course, the actual meterpreter payload. All right, so again, what we're going to do is I'm just going to take a step back, and I've also created a folder on my desktop called Linux Payloads. That's where I'm going to be storing the Linux payload. So whenever you're generating a Linux payload, you have the ability to output it into a binary file or an ELF file, which can both be executed again immediately. So in order to generate a Linux payload, we're going to say Msfvenom. And then you can specify the architecture if you want, although that's not required because you're going to be specifying the architecture within the actual payload type. So if I'm generating a 32-bit Linux payload, I say Linux and then x86, and then I specify the actual type of payload, which in this case is meterpreter. And then I can specify the protocol to use, which in this case is going to be a reverse TCP connection. And then the lhost option, this is where you specify the attacker's IP address or the IP that you want the payload to connect back to. So 10.10.10.5, this is my Kali Linux IP. And then you specify the port to connect back to, so 1234 in this case. And then you specify the output format as ELF, because we're outputting this into an extensible linking format for Linux. And then in terms of the output, we're going to save this on my desktop under Linux Payloads, and we can then provide it with a name. So I'm going to say payload x86, and you can then provide it with the ELF extension, or you can output it directly into a binary. So I'm not going to provide any extension because the binary can directly be executed. So I'm just going to hit enter. That is going to generate a staged Linux 32-bit meterpreter payload for us. And we'll give that a few seconds. There we are. As you can see, it gets the actual architecture from the payload here if we don't specify it explicitly, and it also gets the platform from the payload. So really the most important thing that you'll need to specify whenever generating a malicious payload is the actual payload type, and within the payload type ensure that you specify the target operating system as well as the architecture if that's something that is important to you. Okay, so as you can see, it outputs the payload into an ELF file. And if we head over into the Linux payloads directory, you can see we have the actual payload here. And because we're running this, we're running Kali Linux, we can actually execute this directly. So let me provide the actual binary with executable permissions. So I'm going to say chmod +x and then hit enter. And now I can execute it by saying, by providing the actual execution option here within the command line, which is a full stop and a /, and then I can specify the actual payload here and hit enter, and that is going to execute it. As you can see, it provides us with no output, and the reason nothing is happening is because we haven't set up a listener or a handler to receive the reverse connection. So we'll actually explore that in a few seconds. So I'm just going to terminate that. And in terms of generating a 64-bit Linux payload, the process is again very, very similar. So I'm just going to change the output file to payload x64. And then as for the actual type of our meterpreter module, we are then going to change this into x86, or sorry, into x64. And that's pretty much it in regards to changing the target or the operating system architecture, or rather the payload architecture here. So I can just hit enter. All right, as you can see, that outputs it into an ELF file or a binary in this case. And if I list it out, you can see we also have payload x64 right over there. Okay, so we've generated our payloads. Now, in terms of transferring them onto the target, that is again going to depend on the type of social engineering technique that you will utilize. In my case, we're going to again transfer the Windows payload first to a simple Windows 7 system that I've set up to demonstrate this. So in order to transfer this Windows payloads onto the actual target Windows 7 system, I'm going to navigate into the Windows payloads directory, and I'm going to set up a simple web server within this folder to serve these two payload files. And then I'll head over onto my Windows 7 system and then download the payloads from the Kali Linux web server that I'll set up. So in order to set up a simple web server to host these files, I'm going to say sudo python m. So we're using a Python module called simple HTTP server, and I'll host this on port 80. So once I hit enter, I will be able to access all of these files on the Kali Linux IP on port 80. So as you can see, it's going to serve an HTTP web server on the Kali Linux IP on port 80. All right. However, we also need to set up the handler to receive the reverse connection back from the target system. Now, this can be facilitated within the Metasploit Framework console. So I'll open up a new tab here, and I'll open up the Metasploit Framework console there. So I'll type in MSF console and give that a few seconds. Now, the reason we're utilizing the Metasploit exploit multi-handler is because whenever we're dealing with payloads that are advanced, like a meterpreter payload, we need an appropriate listener to actually handle the reverse connection or the connection that we receive from the target system. So in order to use the multi-handler, we're going to just say use and then multi-handler. And once we specify the multi-handler, as you can see, it's going to say using the configured payload. We need to change that because we need to set up a listener for the meterpreter payload. And in this case, the payload that we're going to be using first, or that we're going to be awaiting connection back from, is the Windows x86 payload that we generated. So this is where you would specify the actual payload option that you had used to generate your payload with Msfvenom. So if you are trying to wait for a connection back from a payload that you generated, and in this case a Windows x86 payload, I would say Windows and then meterpreter reverse TCP. And now, as you can see, it's going to set the payload. If I show the options now, I now need to set the lhost option, or the IP address that we configured our Msfvenom payload to connect back to. So we'll say set lhost to 10.10.10.5, and then set the L port that we had also configured with Msfvenom when generating our Windows payload, which was 1234 in the case of all of them. And then once we're ready, we just hit run. All right. So now, as you can see, it's going to say started the reverse TCP handler on our Kali Linux IP on port 1234. So now it's listening for a connection from the target system whenever the payload is executed. So we can now head over to the Windows system. So I'm just going to switch over to the Windows 7 system. All right, so I'm back on the Windows 7 system, and I've navigated to the directory of the web server that we hosted, which is on the Kali Linux IP address, which is 10.10.10.5, and I have the two payloads here. So I'll download payload x86 because we set up the multi-handler for that particular payload type. So I'm going to click on it and hit save, and I'm going to save it within the downloads directory here, and there we are. As you can see, it's going to say download completed. And if we navigate to the downloads directory now, we can execute it. There we are, run. And that's going to execute and not provide us with any output. And we should receive a reverse connection on our handler now. So I'm going to switch back to Kali. All right, so I'm back on Kali, and as you can see, I received a reverse or a meterpreter session from the target system. As you can see, meterpreter session 1 opened, and we got a connection back from the target Windows 7 system, which has the IP 10.10.10.7, and it connects back to port 1234, and we now have access on the target system, and this is what a client-side attack looks like. Now, again, we haven't explored the process of antivirus evasion and more specifically encoding our payloads. We're going to be exploring that in the next video. And again, you can repeat this process for the Linux payload as well. So again, if I try and get a reverse connection on the Kali Linux system, which is kind of funny because again, I already have access to the system, but I can terminate my session by hitting, by essentially saying Control-C and or exit. So I just hit exit. That is going to shut down that session. And because we're still utilizing the multi-handler, I can set the payload to Linux x86 meterpreter reverse TCP, and then just hit run. and then I can execute the Linux payload just to show you that it does work. There we are, Linux payloads, and I can execute payload x86, hit enter, and as you can see, we get a meterpreter session. So again, that's how to generate payloads with Msfvenom for both Linux and Windows. And now in the context or in the case of transferring them onto the target system, that's something that we can probably explore in another course, in a social engineering course. However, in the next video, we'll be exploring the process of encoding these payloads to avoid antivirus detection. And then after that, we'll also be exploring the process of how to inject a payload into a legitimate Windows executable, which can also help with the legitimacy aspect of things, so essentially trying to make the actual executable or the payload look as realistic as possible and avoid any detection in terms of suspicion from the end user. So I'll switch back over to the slides. All right, so that was the process of generating Windows and Linux payloads with Msfvenom, as well as utilizing or setting up a handler in order to receive the connection. In the next video, we'll be exploring the process of encoding Windows and Linux payloads with Msfvenom. So I'll see you there.